This is the Mba Podcast, released August 16th, 2020. Episode 505. Hardware Revision Control with Kyle Dumont. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Kyle Dumont of Allspice.
Welcome, Kyle. It's, when companies have spice in the name, I usually get excited. You're either going to be about simulating something, doing something with electronics, or you're a Dune enthusiast, and all three are okay in my book. So which ones are you?
So we're not Dune enthusiasts, unfortunately. We're also not.
Okay, after the show, I'm gonna tell you about Dune. So
turn us around. Yeah. I just started reading Seven Eves, so maybe that might be my gateway.
Okay, yeah, that's a good one.
Yeah, we're also not making food, which is the other one we get a lot.
Oh
so.
yeah, right. Yeah. Oh yeah, because allspice is like a thing, is like a type of spice, isn't it?
Yeah, it goes actually great in mulled wine.
So do electronic circuits, if you're so inclined.
Yeah, for us, it was really not surprising. It was kind of a play on what we see evolving in spice. Obviously, there's tons of spice tools that have existed since the 70s. You know, NG spice was kind of like nutmeg spice. Obviously, you have LT spice and others. For us, allspice was kind of this great unifier of, what we could do by bringing together all the spice tools. So a bit of a fun play on words for us.
Yeah, that's great. That's great. Well, before we do that, let's hear about your background. I mean, so you are a hardware engineer. You've been doing some interesting program at Harvard. Can you maybe tell us about that and kind of how you got to where you are now?
So my background is in electrical engineering, product design. I worked at iRobot for a few years doing both industrial products and then also the consumer products. I went from there to help start a 3D printing company called Voxel 8. Some of the listeners, or you might have seen, we had a pretty popular video that was trending for a while of a quadcopter flying off of our printer bed.
Yep. Yeah, I remember that.
And we're actually 3D printing circuits.
Yeah, yeah. And yeah, it was like integrated with the actual, so it was like plastic plus circuits, right?
Yeah, we had basically a dual extrusion system. So we were printing plastics and we were printing kind of a curable silver ink. We had a few different versions, but the most common version we had a solvent that would dry out of the ink and just leave behind like a silver conductive trace.
Yeah.
We also had different versions with like epoxy bases and things like that. We did some pretty crazy stuff to try to improve the resolution and the print quality. We even converted our VF2 Haas CNC machine to be a 3D printer.
Got it. Really got to get those sub-thousandth accuracy and stuff like that, or something crazy.
Oh yeah, we were down to 100 micron trace in space.
Wow. Okay.
We were doing like essentially micro machining using Haas VF2, and then we would backfill the traces in with silvers.
Oh, interesting. So you would make like a small channel, and then that would basically be where you'd basically pour in the silver, inconductive kind of thing in there.
Yeah, we experimented with a lot of different versions. That is definitely one we did. And we could do that actually to do, essentially you're just doing, many, many, many layers of PCBs, but you can do them obviously with, rapid iteration.
Yeah, I remember the video. I remember hearing about it. And then I remember, I don't remember what happened after that. So what happened with that company?
Yeah, things went quiet on the circuits front. Well, it turns out that 3D printing electronics is very hard, and we actually got sucked into 3D printing shoes, so athletic footwear.
As you do.
Yeah, as one does. Nothing to do with circuits as it happens, other than we use the same hardware, we use the same software to drive all the systems, but we swapped out all the materials for polyurethanes and used very similar processes to help, rapid prototyping for athletic shoes.
Huh. Well, I think you missed a calling to bring back the LA lights. Those were really hip back in the day, and I think you really missed an opportunity to make those shine again.
I know. I think they're coming back though. Somebody mentioned that.
Yeah. Okay.
if they ever left.
So I'm curious about the circuit stuff. So was there interest in the marketplace and that sort of thing? I mean, I hope we didn't disparage it here on the show. I feel like that's something we would have been like, oh, yeah, right. But because I remember I've said that about some circuit printing and stuff in the past, but
Mhm.
it was more like usually the phrase that was uttered between me and Dave whenever we saw that kind of stuff was like right. Well, Dave especially was like right tool for the job, right? And there are some people it seems like it does make sense for, but I'm not sure who those were.
Yeah, and that was kind of exploratory for us as well. The first printer we launched was called the Developer's Kit, and the whole idea is we would put this thing out there and we'd kind of see what sticks. And we did find some areas that had a lot of interest for doing one-off circuits and like a rapid prototype design, such as test fixtures were a big one, like ICT fixtures.
Yeah, that makes a ton of sense actually. Just to yeah, you're all built together. Then you have a way to hold the board, and you don't need a laser cut, acrylic and get the
Mhm.
pogo pin, the dance of the pogo pins, and all that other stuff. Well, maybe you still do, but
Yeah, exactly. And the other thing, we were trying to tie in auto routers to that as well. Obviously, auto routers are not super popular, but that's one kind of
no.
it's one application where you're like, well, we have infinite layers, and we just
Oh
need to
yeah,
connect a bunch of connectors on a point on the bottom to a point on the top. And it was one scenario where we thought, maybe an auto router could work, and it seemed promising. We were also exploring antennas, as far as like three-dimensional antennas and what we could do there. Apparently, there's a pretty big surge, I guess, in people, 3D antenna companies.
hmm
For instance, one was just massive phased array antenna designs.
yeah. It basically lets the math people go crazy, and you're like, oh, you have a third dimension now. Okay, well, go all fractal on it. So okay.
It's absolutely, it was yeah, it was over my head a little bit, but it was
I'm sure there's Maxwell's equations, and many, many, teraflops of processing to do that kind of stuff. But yeah, wow, that's some crazy stuff.
yeah, yeah, they were pretty neat.
How would you? So when you said like the multiple layers too, how were you connecting between the layers when doing this?
Well, it depended on the iteration of the product, but for the simplest case of like the plastic and the multi-material printing, plastic and silver printing,
hmm
we would essentially print the plastic layer, leave a trough for the silver, and then still backfill it with silver.
Mm.
We just wouldn't print over the top of any layer, so we would print basically a little via in
Oh, okay, yeah. So basically, like on
filling.
individual layers, you'd have like a little circular cutout area, and then that would look like a VO or similar, like a
Yep.
fillet or
Yeah,
whatever they're called.
exactly. The other kind of cool thing is we got blind vias for free, inherently, because we're not doing a drill process through the entire board. We're drilling as we go if we were drilling, or leaving a trough if we're printing.
hmm
We got those blind vias for free.
Mm. And then what was the resolution you could get on that sort of thing?
Well, I mean, that was one of the problems with the dev kit printer. We were still doing FFF, so basically fused filament deposition. So it was, we had to basically print a plastic and then be able to fill that trough. So with that process, we were probably down to somewhere around eight mils
Okay,
trace in space, and so certainly nothing that would even be industry standard, which
sure.
is one of the reasons we ended up moving to another industry as it
Uh huh.
happened.
Yeah.
But with the other process, we were able to get down to like 100 microns.
Yeah, that's the milled and like subtractive versus additive, that kind of thing.
Yeah, and just using significantly more expensive pieces of
Yeah.
machinery.
Right. Right. Yeah. That's. I mean, that's cool. I mean, what about the silver stuff? So, like, how that was another thing that I always wondered about was like the connectivity seemed like a lot lower than copper, but maybe that was just the type that I was looking at. Like the ones that I always saw were like the ink. There was another one. I think Volterra was one that was like a
Yep.
ink based kind of all in one thing, and that one really didn't seem like it seemed like an interesting idea, but it just in terms of the capabilities, it didn't seem like it was there.
Yeah, you do end up with some interesting properties, especially if you're doing anything high frequency. In terms of conductivity, you know, it was something around the order of like 1/10, maybe one
Mm,
fifth of the conductivity of copper. But at
okay.
the end of the day, you can just print, because you're printing this stuff, you can print it 10 times thicker,
Yeah.
and you wouldn't even notice it.
Yeah, that's a good point.
Being
Yeah, and I guess
thicker.
if you don't care about most of the time the Z height, you wouldn't. think about, and
Yeah.
especially if you have control over each layer, you don't have to worry about like core and prepreg stack. I mean, you probably have to know the dielectric constant of the material in between and blah 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 if you're doing RF, but you could control that much finer instead of having to
Mhm.
go out and order prepreg. You just make your own effectively, and
Yeah.
hopefully it's consistent enough over the spacing.
Yeah. That's actually what we were doing when we were, when we moved to the CNCs. We were actually printing epoxy, glass loaded epoxy. So it was actually fairly similar
Oh,
to
interesting.
FR4.
Okay, and then you would machine glass loaded epoxy.
Like I said, it was a dirty process.
Well, okay. And so is
Yeah.
that company still around and still doing shoes and stuff like that?
Yeah, yeah, Voxelate. They're doing shoes, focusing on basically stylizing the uppers of
Mm.
shoes. So, in the time before I did leave the company, I learned more about athletic footwear than I ever thought I would. So,
Mm-hmm.
I'm sure there's maybe a sneakerhead segment that I
Uh,
can join or something like that.
I have met some people that are like in that crowd. It's like they're really into it. Like
There's a
really,
lot of
really,
passion
really.
there.
Yeah.
Yeah,
I don't understand why though. I mean,
yeah.
I guess saying they're just shoes is like some coming up and being like, Chris, it's just electronics. Okay. Yeah.
I built my life around this.
Yeah. Right. Right.
Yeah. Yeah, so they're printing stylizing uppers, so basically printing polyurethanes. One of the cool things was that they were able to use very similar bulk materials that the manufacturers are going to use when they actually manufacture the shoes for real. Whereas other processes like SLA was like select laser annealing, I think it stands for. You
Mm-hmm.
have to make something that cures with UV light, and then if you have something that cures with UV light, it's inherently not going to have the same properties that you might
Yeah.
want to have in a production shoe.
Right.
So that's kind of their current value prop. At least last I touched base.
Yeah. That makes sense. Okay. Cool. So, and you were doing the control stuff there, or what were you doing on that side of things?
Yeah, so startup, it moved around a little bit, but when I joined, I had a team that was basically in charge of designing the desktop 3D printer, that dev kit that we launched initially. So it was pretty cool. It was, very, very much what I would consider a robot, a lot of electromechanical parts. We had a pretty cool modular print head. So we had like pogo pins that would connect to the print engine, and you could kind of pop the cartridges in and out.
Yeah, which the VCs love, so that you can sell the cartridges like everyone wants
Oh,
to be
yeah.
an HP or a what's the coffee maker,
Oh, yeah, the Keurig
Keurig
K
pods.
cups.
Oh yeah, yep. Disposable stuff is great for that bottom line.
Yeah, well, that bit Stratasys and MakerBot around that time. They had
Yeah,
something
yeah,
called the Smart Extruder, but
yeah.
I think they
Nobody
got a
liked
lot of
it.
grief.
Yeah,
Yeah,
yeah. Yeah. Oh well. I mean, 3D printing in general. I mean, like it really did have this rise. I mean, like it's obviously normalized now, and
mm,
it was institutionalized before, but like now, like the hobbyist side is almost even institutionalized too. And it's just like, yeah, you just buy a 3D printer. What's the question? Whereas,
yeah,
like back however many was it 6, 7 years ago, whenever that happened, it was pretty hot. I remember.
yeah. There's the 3D printing industry has a lot of boom cycles. It's still an industry that's trying to find that mainstream hook. Surprisingly, actually, like shoes and athletic footwear has been one of the
Mhm.
places the industry is going, but it's yeah, it's struggling to find that mainstream
It's
adoption.
limited, I'm sure too. Yeah, so they're going to keep trying other things, and
Mhm.
yeah, the downside of course is always the raster versus like molding type of thing. Like it's they keep saying like, oh, it's for production, it's for production. I'm like, oof, okay, well, it's a lot faster to
Yeah.
just mold things, especially in plastics.
Yeah, the quality can get there, but it turns out that like, jamming a bunch of molten plastic into a mold is pretty cheap and pretty quick.
Yeah, every time I talk to a mechanical designer too, they're like quoting out like parts, and I'm like, yeah, well, the mold's gonna be $10,000 or something like that. I'm like, okay, like what's the part cost? And like two cents.
10 cents.
I'm like,
Yeah.
oh, you mean like a big cap?
Yeah. It's
It's
like
like,
that fixed. It's all fixed cost.
yeah, that's pretty crazy,
Yeah.
and they can really crank them out. So yeah, that's plastics, huh? Okay, well, that's a different game.
Yeah.
Anyway, what'd you do after that then? That was before iRobot or after?
That was after iRobot.
Oh, cool.
So from there, I did a little actually independent consulting for electrical and firmware engineering.
Hmm.
Worked on a couple cool projects, and then started at the grad school program.
Nice. Yeah. And tell us. So when you wrote to when we started talking about you being on the show, you told me about this, and I looked at it, and like this is the first. Not that not that I'm thinking about doing this, and I don't think I actually could, but like it was the first time I was like, oh, that actually like that MBA program makes sense because it's not just an MBA program. So what is this thing that you just finished?
Yeah, it was. It's called the MS MBA program. It's essentially you're combining an MBA with a Master's of Science. I think the Master's of Science is in a generalized engineering sciences, but you essentially get to custom pick what engineering classes you want to take.
Oh, cool.
It's in 2 years, like a typical MBA program. They add in some summer classes and winter classes, so you kind of can can get enough of those elective credits to get both degrees.
Oh yeah.
Most of our class, maybe not surprisingly, focused in either data science or software.
I guess if you're into that sort of thing, whatever.
Yeah, yeah.
Yeah.
But yeah, it was great. There's 30 of us in the program. Although you're pretty well integrated into the general like MBA class, which at Harvard was 900 people, give or take. So they kind of throw you in like the first year you're doing kind of the standard core MBA program, and then the second year you get to more or less swap out some of your MBA classes with engineering classes, which was perfect for me because the engineering classes were enough to sink my teeth into something while getting some good practical value and networking and all of the things you typically get from an MBA program.
Yeah, that makes a lot of sense. I mean, the thing that always like weirds me out about all this, the MBA stuff, is like all these people that come out of these programs and they're like, yeah, we're gonna go work in startups, and it's like, okay, what's your background? They're like operations, and I'm gonna go work at a startup that does software. It's like you don't know anything about software. Like, and I realize that there's other fields that are required, but it's like there's such a strong pull into tech from
Yeah.
MBA programs, and yet there's like no tie to the technology side of things. And
Mhm.
so like the fact that that exists, like I never understood that. Aside from the fact of like people that are like, I'm going to go work in tech after paying $80,000 to $100,000 a year for 2 years, but whatever. That's its own thing. But
Yeah.
yeah, it's good that they're doing a technical side, I think.
Yeah, they're really trying to beef up that side of things. I think the MBA programs realize that you can't have a class full of people from the finance industry
Yeah,
because you're
right.
just it's so important, and especially in an MBA program, most of the learning is centered around discussion from the students, and so having the voice in the classroom that's saying like, "Hey, this is actually how things are built," ends up being pretty important. I think they realize that.
Yeah, well, that's great. I mean, it's yeah. I think I wouldn't expect the people like yourself or other people that are graduating from a Harvard MBA program that are like, I'm going to go become a coder now. It's like that's not like likely an output from it. However, having the context of like, oh, this is what the software people that I'm asking to do all these different things, it's like, oh, that actually makes a lot more sense then. So from that perspective, it's really good from a being able to communicate with the people that you're building teams around and understanding their pain and things like that.
Yeah, and knowing what really goes behind executing on
Yeah, right.
something, so you don't end up.
Right. Yeah, so we got to build a Android app and an iPhone app and a desktop app and 6 weeks. Are we good with that? We had three
Yeah.
engineers. Each one does one of them. Yeah, so 6 weeks. Okay, cool.
So yeah, I'll talk to you in 6 weeks. Bye.
That's right, right, right. There's snacks in the kitchen and ping pong table. So I think we're a startup and we're good to go.
Yeah, we're
Uh,
good.
yeah.
Yeah.
What about? I mean, we've had other people who are MBAs on the program before,
Mhm.
but tell me more about the class. I have a friend who went to Booth, who
Mhm.
was in tech, and it was interesting hearing kind of like the people that he interacted with. But tell me more about like the crowd that you kind of interface with, because I also have learned from people that I know who do MBA programs. It's like no, it's really about like getting to know other people and building connections. Like that's kind of the real value, especially if you're at a place like Harvard.
Yeah, I think that's true. Typically wouldn't go to an MBA for like the core learning or like the classes themselves. Although I think what an MBA is good for is just exposing you to as much material in a short amount of time as possible.
Yeah. Yeah, and especially if you have like high profile access into like a if you want to do consulting, you can go do an internship at McKinsey easily. If you want to do, if you want to go do a startup, you can talk to a bunch of VCs easily. You just kind of like lean on the name, it feels like.
Yeah, yeah. I don't know if I've gotten quite there, but that's the
Oh,
idea. I,
oh,
I
lean
would
into
say
it, Kyle. You should be like, "Oh, hello, I'm Kyle from Harvard."
yes. Got to work on that
Yeah.
intro. I would say my one liner for an MBA is basically it helps you sound like less of an idiot in most conversations,
Oh, okay.
or many anyway.
Okay.
The cases, so you're basically doing all case studies primarily for learning, and so each case study is a different company, or maybe it's about a country or something like that. So you just get exposed to like a lot of different scenarios, and then you spend an hour talking about that, and you'll do 2 to 3 of those a a day during the school year. And you're also surrounded by, one of the other things they try to do is just bring in the most diverse group of people that they can find.
Yeah.
Hence why they
Yeah.
wanted some engineer joining the class.
Good. Good.
So
Yeah.
yes, believe it or not, in some pools we are diverse.
Oh, good. Yeah. Yeah.
And then so you get those experiences from meeting people from different places or backgrounds or industries as well.
Right. Right. And then you're getting a master's in data science or computer engineering from Harvard, and you're like struggling over adding and subtracting in the accounting classes because none of it makes sense.
Oh god, it was so strange going from like advanced computer microarchitecture, then walking into, I think I had like a tech sales class that I took, and it's
Oh man.
just the whole atmosphere as you walk, from the engineering campus to the MBA campus. It's just like switching from like right brain, left brain. Yeah,
Yeah. Yeah. That's great.
it was interesting.
Yeah. So you mentioned 30 of you, most of you did computer stuff. Do people do other, like, is there like a option even to do hardware? Because I know Horowitz and Hill are both Harvard folks, so there's definitely
Yeah.
some firepower there.
Yeah. So the engineering school at Harvard is really focused on PhDs. So the hardware classes are taught maybe slightly less often, which you can get away with if you're doing a PhD because you're there for 4 or 5 years.
Right.
I will say there weren't as many of those classes. I took computer architecture. There were some hardware classes for sure, but there were definitely a lot more data science and more of a selection
Yeah.
for computer
Yeah,
science.
of course. Yeah. I mean, I just from a numbers game, it makes sense. Okay, well that's cool. So let's get into the data science and stuff you're doing with this. I mean, you're kind of merging it all here. You got the business, you got the data science, you got the hardware. So tell us about Allspice. What are you trying to do with Allspice?
Yeah, for better or worse, I'm not sure what else I would do if I wasn't doing Allspice. It's that perfect intersection.
Right, right.
Yeah, so Allspice is really focused on building a Git-based automated release workflow for hardware designs. This really comes from my time spent doing product development. It always felt like our design, collaboration, and release process really was never suited to do what we were trying to make it do.
Uh, Kyle, I don't know if you've heard of zip files. You get
Yeah,
to
zip
email them back and forth. Sometimes, if you're really feeling fancy and spunky, you can use a Dropbox link. So I don't know what the problem here is, man.
sounds perfect,
Yeah.
and that's pretty state of the art.
Plus, I label it if it's Rev 34. I rev it to 35, and we're done. So
Yeah, Rev 35, no dash no for real this time.
that's right. No, for real this time. Yep. Oh
Yeah,
man.
exactly. So it's not surprising reflecting back on it, in based on what we've learned doing lots of interviews with our current company. A lot of it's because the tools and the processes were built around waterfall design, where you could take the time to do all the documentation ahead of time, line things up, get all the pieces in the right order, and then you're only doing maybe a release every 6 months or so, maybe 12 months, depending on
Mm,
the industry.
yep.
But as these time scales are being compressed because you have software is now iterating very quickly. Even mechanical engineering is getting better at iterating quickly, especially using 3D printing, like we talked
Sure.
about.
Sure. Don't forget chip companies deciding to merge every other week. So,
Yeah,
you
that
got
makes
to
it
change the
easy.
data sheets that are attached to each design that you do.
Oh yeah, forget it. I think those data sheets, at least that I've ever seen, are usually always out of date.
Oh yeah. Yeah.
So yeah, the EEs are kind of stuck in the middle of this space, and not most are pretty cognizant that the tools are at least, there's a lot of friction around the process of iterating. So, when I went to start the EE team at Voxel 8, the 3D printing company, I did what most hardware startups do, which is we used Git and GitHub to actually host our CAD designs, at least for electronics. But what we found is that Git may work to give you that centralized repository, and I know you've talked about this some with contextual electronics. The environment that's built up around Git and GitHub ecosystem for software just still doesn't exist in hardware, primarily because Git isn't set up for those like binary CAD files.
Well, yeah, but not every CAD file is binary. So this is where I usually, I'm snarky about it,
Yeah.
obviously. And yeah, it for Altium or other, Cadence, whatever, all the binary files, it doesn't work. But to be fair, for KiCad and Eagle, which use ASCII-based files, it still sucks. I mean, it's still like if you're doing a
Yeah.
diff between different things. Maybe we could take a step back real quick too.
Sure.
Could you try and sell people? Okay, so like you just hired someone at Voxel 8 who's a hardware engineer. They've
Mhm.
never touched Git before, and you were going to try and sell them on it. Obviously, you're in charge of them anyways. It doesn't matter. But you're a good manager, and you're trying to sell them on the idea of it. Why should people use Git in the first place? Because this is something I've struggled to explain on the show before, but I'm very much into this workflow as well. So, like,
Mhm.
what would you tell that new hire?
One of the things we find is that a lot of engineers that are entering the workforce right now for EEs, they're doing firmware design as well. And actually, a lot of electronics engineers are doing firmware design as well. So, one of the clear benefits is if you're doing firmware, you're going to want to understand that process anyways, because it's so industry standard for like that firmware software world. So,
Yeah.
getting everyone in the same system is can be that much more powerful. At Voxel 8, I always had somebody that I could go to on the software engineer, and he's actually our lead software architect now for Allspice, who was like my guru for
Yeah.
helping
Yeah.
understand Git.
Yep.
In terms of the core utility, for one, it's this is where hardware is not there yet, and this is where we're trying to get it into this uh, into a place where you can get some of the real benefits that Git provides, like being able to actually segment your design changes based on a branch.
And we'll dig into that too. I think that's something we can definitely. I think that's a key piece because that's so tied to like manufacturing ideas as well, right? Of like branching ideas out and trying different things. So
Yeah,
specifically on Git, though, I mean, could you maybe also just even further step back for people who haven't even heard of it before? What is Git and how does it fundamentally work?
Git is a protocol that enables essentially design revision control. It's particularly designed for those ASCII text files. What's interesting about it is that it actually saves files based off of save new versions based off of the change, the delta in from one version to another.
Yep.
And so it helps save space that way. And that's what made it a little bit different from like SVN Subversion that came before it. But essentially it's giving you that revision control, design history for any files that you put into it.
Yeah, it always like wigs me out. It's like so I do teach a little bit with this in contextual electronics, but it's like, yeah, you go into the .git folder that's like in a Git repository, and you're like, oh no, it's all there. Like you just have the differences from the first day, and like when you like, so if I go and clone a direct or a repository that you created, and I
Mhm.
pull down that .git directory, and that's what defines the Git repository itself and all the configuration stuff that's in there. It's like I don't just download the latest files. I download all of the history and I get to see every single change that you've made, going from A to B to C to D to E, all the way back to Z. And then Z is the current day. And you can see all these different changes that might have been happening and tried and revised and all that, everything else there.
Yeah, when you do that Git checkout, it copies everything to your local repository. And you can very quickly hop back and forth between it, which is what makes Git kind of nice between different versions. And then to resync, you do run the Git pull process, and that'll essentially pull from the centralized cloud version to your
Mm-hmm.
local repository.
Yeah, I feel like that's another important like element too, that it is that there's everybody has a copy of this history.
Hmm.
And then there's what's the centralized one? So like if I'm on github.com or GitLab, that's called a remote, right?
Like your remote, yeah.
Yeah. And so the remote is like the kind of the reference that everybody has. But then I'm making changes on my local copy. And then I can go and say, hey, my changes are getting pushed to the remote. And this is probably the most boring podcast that anyone has ever listened. Every hardware engineer is tuned out, but it actually really matters because now it's like you're not just sending the end files, right? And this is actually probably coming back to the binary ideas. It's I'm not just sending version 34 moving to version 35. It's I'm actually changing R1 has moved from position X 34 X 72 to position X 34 Y 95, and it's like basically just change. You can actually have these discrete changes that are tracked, and we've seen this in some other tools as well, right? So like the web-based tools try and do all this stuff on an individual move basis, right? So they actually track history of like, oh, user one moved R1 from those two coordinates to the second set of coordinates that I said. And it's like they actually just track all of those things as historical elements. But now it's like basically the user decides when those changes get pushed. I make all the changes on my local copy. I now say, I've decided now's the hour, Chris, time to make that change. I push a commit, and then that basically bundles up all the changes that I've made, and I can then send that to the server.
Yeah, yeah. One of the interesting things for Git, as you mentioned, is there's that separation between the local and the remote. So what happens is to push a new version is actually generally two steps. First is you do that commit, and that commits it to your local .git folder, your Git history on your local computer. And then when you run the push, that's when it actually pushes it now to the remote server. Everyone else can access it.
Yeah. There's an XKCD about Git that where it's talking about like, like it's like this highfalutin like, oh, Git is the most like magical thing ever, and they're like, well, what is it really? And they're like, yeah, it's a set of commands that you remember, and you try and use them possibly to make your thing work finally.
Yeah.
It really does start like that, and it sucks when you're getting started, but once you start to get into it, it can really open up your workflow and try different things.
Yeah, what's beautiful about, and it's hard to say whether it was more Git or more GitHub, but was the kind of the workflow that started evolving around that and the ecosystem that evolved around that. And the hooks were there in the Git protocol. For instance, literally a function called like a Git hook, where you can have it run every time you push a new version, you can have it run a series of scripts on your design. So if it's software, you could have it essentially, check your formatting or something like that and all your indentations and things like that.
Yep.
But for us, we look at using that essentially to start to build this continuous test,
Yeah.
continuous integration process that has also evolved in the software discipline.
Yeah, yeah, that's a great. And I love the digging. Before we do that, I would call out. So Jesse Vincent, who's been on the show before, he actually gave a talk at KaiCon last year, and he used Git hooks. So like for his example, and I'm sure this is stuff you guys do too, but his example was for KiCad. When you push a new revision or you tag it or whatever the finalized version is saying, hey, this is ready for production. There's some way he can send that as a input to his Git repository, and then it just starts spitting out everything. It auto generates Gerbers, it regenerates a schematic file, it regenerates the BOM, it does all this stuff that you'd have to do anyways. But like, why shouldn't that be automated? It's like, hey, I'm ready for production. Spit out every file I need to send to a manufacturer right now. And that's like a great example of like that's a hook that drives all of these other changes that then the files just show up somewhere and you're ready to go for manufacturing.
Yeah, absolutely. I mean, that's a perfect example. You can really go from there. Of course, there's this whole environment in industry of CI that didn't even exist 10 years ago. I think in
Yeah.
software to this, at least not to this degree, where you can run kind of an endless level of test and release on your design files. And I think there's actually, I mean, we believe there's even more power to do that for hardware because there's so much information that you need to go gather. I mean, we talked about data sheets, but if you can actually pull that information together to start automatically validating some of the manual processes that we're doing now, one could be building that documentation like the bill of materials. We also look a lot about at what other documentation you could automatically be generating and updating for each version, such as building a power table. Going through, we know all the power ports on your design, and we can basically go through and maybe with a little help from you to fill in the blanks, we can build out a power table and then check, let you know this is the amount of current that each power supply is drawing,
Yep.
on average or peak and whatever else you might have. And not only that, but you can do that with the same diff process as you can on the original design. So you can you can look at how your current, maybe on a particular power supply, has changed from one version to the next.
That's right. Yeah. Right. You could set limits then too. But can you explain what CI is? Because I think you said that, or maybe you said
Mm.
what it means, but can you explain it?
Yeah, CI is continuous integration, and it means actually it has a pretty broad usage. But essentially, you can set up a series of tests that run in your cloud on that remote repository, where every time you push a new change, it can kick off a series of scripts or processes to either produce some documentation information, produce those releases, maybe deploy onto a website if you are talking about a software web application.
Yeah. Yeah. I forget where I heard about it. Maybe it was a guest on here. And if so, I'm sorry. But there was someone who was talking about CI at some point, and they were like, well, I think a best case scenario would be if you sent so say you were doing firmware and you go and check in a change and it's just a small change, right? You're like changing a variable. But what should happen then is like the firmware should get compiled, it should get built, it should get sent to a test board that might be hooked into a test stand. And then the test board basically runs through a suite of tests. Maybe there's 100 tests and it doesn't need to run them all, but why wouldn't you just run them
Mm-hmm.
all every time? And then the one change that you've done, does every test still pass based on this small change that you made? And if it does, then it's like, okay, the change that I just made, that's, the small, maybe I was just literally changing the name of a variable, but like it propagates all the way through the system. And at the end, there's a test report that says, yeah, Chris, you didn't break anything, at least nothing that we care about. And then that basically, gives you this confidence that you could continually, well, integrate, but I mean, you could continually try all these things and test that it's been working. I think the hard
Right.
thing is the testing it feels like it's a lot less well defined
Mm-hmm.
than it might be in a software world, because it might involve some real world characteristics that are tough to measure. Test stands and test equipment and all that other stuff.
Mm-hmm. Yeah, we actually did that. What you mentioned at Voxelate, we had a build server, and it would push a new version of the code, and we had it run through a whole series of unit tests on the printer. It would go like jog it to all the coordinates and make sure it didn't crash. So I think that's a great idea.
Yeah, those are like high level things that like it absolutely must never do these things, right? It should never
Yeah.
crash into the edge of the printer, right? But
Mm-hmm.
who knows if one small thing causes that to happen, and it's good to just try it to make sure.
Yeah.
So, is that what
Yeah.
you're kind of building with at Allspice then as well? I mean, or is it more still on the software side and working with Spice and testing these inputs?
Yeah, so we'll say we're focused on the design files initially, though that's definitely something we want to talk about and have more conversations around, because that is it's so specific to people's hardware. We certainly will help people build that type of process, but we also want to take those tests and just emulate them as well. A lot of people get, in really simulation itself is, I believe one of the biggest flaws with simulation is that it's so focused on getting like the perfect fidelity, third, fourth, fifth order, fidelity for simulation models. And for many cases, that's exactly what you need. But there's many cases where you're almost better to get a breadth of design information, such as like, did I hook up TX to RX? Where you don't need a fourth order
That's
equation. It's
never
just
that's never happened, Kyle. I don't know what you're talking about.
if you have, yeah, if you haven't switched TX and RX as an engineer,
You haven't lived. You
you
haven't
haven't
felt the
lived.
power of soldering
There are two
wires.
types of electrical engineers: those who have swapped TX and RX, and liars.
That's right.
So, so one of the things we look at for this is just getting you a breadth of design knowledge, and then we can drill down, like both using basically custom information from the user. So start putting more information into your design or into your documentation, and also improving our own database of component and model information for
Of
this.
screw ups.
Yes, yes.
It
Learn
almost
by
sounds. I
failing.
was really like into like the idea of like checklists and Atul Gawande's book about checklist
Mm,
manifesto and stuff like that. And it almost sounds like you're automating a lot of that stuff, right? You're basically pre-flight checking everything just for like idiot proofing it to make sure that you didn't, I mean, you could do DRC stuff and you can do all these. There are some built in, but it's not unified anywhere.
Yeah, and most of those things take so much effort to set up for the amount of utility you actually get out. I think it's one of the reasons that they're not as broadly adopted. But certainly, actually, one of the blog posts I've been meaning to push out is the design review checklist.
Yeah,
because it's something that we talk about all the time. And every time I go to a new company or talk to a hardware engineer, it's always everyone's coming up with their own design review checklist. So.
Yeah, it would be nice to have some kind of that would be great to have like a standardized one. I think we've talked about it on the show before too.
Yeah.
And like, so I had asked about it, and Charles Aylward had submitted some, and like I asked on Twitter, and a bunch of people did. And it's like, it's really tough because every board's so different, and that's usually what it comes down to, is that there is so much difference. But just having a starting point of like, did you check, just having like a published version somewhere, I would point people at that. So if you go and make a blog post and say, here is, go start like a designchecklist.com, I'll point people at that, just as like, you need some kind of starting place for beginners. And
yeah, it's a template.
Yeah, exactly. And people are going to customize it. It's more about building the habit more than anything else, I think, because I've had design checklists before, and the number one thing that happens is I just forget to do it. That doesn't help. But if it was part of a check-in process or something, and it was like, even if it just sent me a text message, just like, "Hey, Chris, did you check this against your checklist?" That would be great. So that's probably one for more of the board houses and all the others out there. But yeah, send me a text message reminding me not to be an idiot, and that would solve a lot of problems.
Yeah. I mean, if it gets to the board house at that point, hopefully they catch it. I mean, I've definitely had to send many thank you messages to board manufacturers,
to CAM engineers. Yeah, that's true. I mean, and that's true, I guess so. But like, I don't know. I feel like even like a thing like when you send it off to a really good check, that would a board house would never. Well, maybe they would check it, but most people wouldn't need to send it, right? So if I'm sending my Gerbers to like an Osh Park or whoever, the check would be, hey, Chris, do each of these parts actually correlate to a real component? Do you have MPNs for every part here? And it's like, well, that is not necessary for making a board at all. However, that is almost always the source of like me putting the wrong footprint down, is because I haven't gone and like, I'm like, oh yeah, I know this one. This is a SOT 23 for sure. And it's like, no, that's a SOT 523, you idiot. Like there's no way that's what you actually, like, and it's just, if I would have gone and like really verified the data sheet, that's just an impossible thing to check at a board house.
Yeah, I mean, it's on page 37 of the data sheet. I mean, the best is when you get those data sheets that are like, these are all of like the variations of this footprint, like a crystal,
or honestly, I don't know if people would be willing to do it, but like if there was a board house that said, hey, no, actually you have to send it your MPN for this part. If you don't, we can't check it for you. But if you do, we can double check that all of the footprints are the right ones. That would be a great service to have, like a check of MPN versus what's actually on the board, because that MPN is always tied to the specific footprint.
Yeah, that's actually one of the things we talk about a lot. It's just going through the design metadata and saying, do you have a manufacturer and a part number specified for your parts, and how many of the parts are without? Not to say, give you some big red flag and say like, you have failed, but
right,
give you that.
You might want to check this kind of thing.
Yeah. Particularly the area we focused on initially, was connecting with those teams that are using Git to manage their hardware designs, because where we do want to do ultimately is make it easier to adopt. But initially we're finding the teams that are already adopting the Git technology or Git workflow process. And the first thing we did is we built essentially a diff redline into that. This is kind of, as we spoke about, is like doing that delta comparison for software. Git can go in and tell you, these are the lines, these are the variables even that have changed.
Yeah, like a diff is like a side-by-side of like showing like, hey, someone put a new chunk of code below this function. There's a new function here, or they deleted that function or something. So
essentially we go through and we build the visual red line. So we take the schematic and we highlight, green for added, yellow for modified, and red for removed components. And then we also take that textual metadata side we show those side by side to tell you what's changed in the design.
Cool. And how has the feedback been on that sort of thing?
So we're just getting it out there, but generally seems to be good so far. I mean, we'd love, it's totally free to use. It's on our website, so we'd definitely love more feedback. We're working with
Kyle,
Altium.
what I was gonna say, what has to happen here for Chris to use this?
So we are currently
I know
supporting.
you had to focus on people that actually pay for things. Huh? Is that what you're trying to say?
Yeah. There's
That's
that
fine. Hey
though.
man, it's a business. It's a business. It's fine. It's fine.
For sure. And there's really interesting segmentation and like who uses what CAD tool.
Yeah.
Which is maybe, I don't know if other industries are like this or if electronics is unique, but pretty much seems like if you know the company, what industry they're in and how long they've been around, you can tell with like 95% certainty what tool they use.
Interesting. Well, give us some of this over. I'm curious, just like it's like broad strokes. Like what is, so like if someone's like an aerospace company with more than 500 people, what are they using?
It's probably Mentor Graphics. Well, it's either Mentor Graphics or Cadence. Actually, aerospace is kind of a unique area where if you're talking like Boeing, they literally use like all of them. It just depends on the division.
Because they're that big. Like they're an amalgamation of different old companies.
Yeah. So some of there's large ones.
Huh.
But so larger and I guess more larger companies that have been around for a while are typically using Cadence design. Altium really has that small and medium size company segment.
Yeah, and like especially consumer, it's like good luck if you're doing consumer and you're not. Yeah, if you're a small company and consumer, it's like okay, Altium is it.
Yeah, but it changes all the time. I mean, obviously, you've talked at length about KiCad is really growing and really moving up market as well in some places.
Yeah, hopefully. Yeah, we'll see. Yeah, I think that's the other interesting thing is that like as it does move up market specifically, like there's companies that are interested in paying for help. It's not just like just hobbyists or just people who are like open source nuts. It's people that are maybe looking to use other programs, but they don't want to deal with licensing, whatever. And there might actually be money there. I think that's really the thing for like companies that are servicing, audiences. It's like, look, you got to pay at some point. And there's in order to design specific services for something like that, you gotta choose your battles. So I get it. I think it's interesting to me that Altium didn't have this. I mean, why, or do they have this and it's just not Git? It's like the other one.
So Altium is they're building a tool called Altium 365. This is kind of their cloud based design review system.
Okay.
And so we're really focused on building that analysis and kind of getting early to market with the customers that really are interested in being on the early edge of building some of these workflows. Right now, using GitHub, also using GitLab and Bitbucket would be like the three major Git hosting services. Using those as the platform to do the design review on. But potentially we could use Altium 365 as well.
Oh, you're saying 365 doesn't work? It only works with their internal storage instead of like an external hosting, like a GitHub?
They actually use Git as their hosting, as I understand. I think most of that is hidden from the users, which most hardware users would like.
Yeah.
We're really focused on people who want to really kind of customize and own that system a little bit.
Yeah.
At least in the initial days.
Yeah. So you mentioned a little bit that a lot of the younger engineers are firmware plus hardware, which makes a ton of sense. Are the teams like kind of small and integrated enough that they have software, firmware, hardware kind of all working together? Is that like a kind of a best case scenario for what you're talking about?
Yeah, I mean, you typically anytime a company scales beyond 10 engineers, you're going to have folks that are just dedicated on firmware.
Yeah, true. Yeah.
You typically will have more and more. I mean, hardware designers are becoming, as far as I've seen, generalists doing some firmware, doing some system level design. And then usually you'll have at least a good chunk of your electronics team now, especially at a newer company, will be kind of a general electrical firmware designer.
Yeah, it makes sense. So your workflow on the website, on the allspice.io website, also calls out PLM. And so, are you guys tying into like a Arena or similar, or is it more tied into the Altium PLM, or what are you doing with that?
Yeah, that's obviously a huge piece of the system for hardware engineers. We're still handling that on a case by case basis now. We're a bit on the outside of those systems and just using the APIs for querying and basically using the design the information in the CAD design as kind of like our liaison to the PLM systems because they tend to pull that information from PLM. But
Okay,
ultimately, we'll need to be able to have an integration to push either the design releases or the design review information.
got it. Yeah, yeah. PLM is like its own kind of beast, and it seems like it's a lot of like custom integration. It always feels like as well, and it's only when you get to a certain size anyway. So like you never really hear about it until like you're hit in the face with it. It's like
Mm-hmm.
there's no easing into it. It's like you go to a company and usually they've already got a huge PLM system, or yeah, yeah, it's tough. It's tough to work with.
Yeah, absolutely.
So let's talk a little bit about the flow. Okay, so you mentioned branching before, but like, what's an example scenario that like walk me through someone making a change, and then what happens? Like, what does that change? How does that change ripple out, especially through Allspice?
If you're making a change, the general idea initially, especially using this kind of workflow, is to be very focused about the design change you're making. So if you're updating something to solve a particular problem, say, maybe adding ESD protection
Mm,
on some input, you make just that change, or at least some way make it in such a compartmentalized way that you're solving a particular problem, and
okay,
then you can commit that. And so instead
okay,
of making all of your changes and pushing everything all at once, you make a single change that solves a particular problem. You can commit that, and then you can make the other changes that you want.
okay. So this would be kind of like, so like in GitHub, there's like issue tracking as well,
Yeah.
and I actually had to do this recently where I had as luck would have it, I had swapped TX and RX. And my firmware engineer called it out. He's like, "Hey, Chris, you did that thing." I'm like, "Okay." And like, so it had like an issue number 5. That was like the number
Mm.
of the issue. And I went and made that change. I saved my schematic. I committed that change. And then I actually referenced the issue in the commit message. And I said, "Hey, I swapped the RX and TX back to how they should be. Closes number 5." And that was like
Yeah, closes number
a
5.
GitHub message. Is that kind of what you're talking about?
Yeah, yeah, and that can even go through and close out that ticket. Exactly. And so by compartmentalizing it, you can make it just easier to basically go back through that history, see how the issue that you created or that maybe the firmware engineer created links to that particular design change.
Mm.
And then you can easily cross-reference, why was this thing changed? Oh, here's the issue and all the documentation about
What if I don't like making changes like that in an atomic way? What if I'm
it.
used to messing up a lot of things at once and fixing a lot of things at once, Kyle?
Just throwing it all in
Yeah,
the same change. Yeah, that's hopefully when you're working on your own project, maybe that's digestible.
yeah.
But yeah, people tend to like to look at when they're reviewing colleagues or reviewing other people's
Hmm.
designs.
So what about at the beginning of the process though, when you are just creating things? So like fixing, I totally get. What about
Mm.
the initial creation of all the mistakes that I'm going to make?
Yeah, it's the beautiful things about issues is you can kind of log them as they come up, and then you can have that very clear checkboxes closing those issues as they're resolved. In terms of just like bulk adding a bunch of designs, some of those earlier diffs or earlier versions, may or may not be the ones that you reference the most for the diff,
Okay.
because you're going to get a whole block of like new parts added.
Yeah.
But you do tend to get a good overview.
Yeah. So like I track changes in like contextual electronics as I'm like going through and building each thing, and I'm like doing the layout for the like recently I was connecting a microcontroller to a logic level translator, and so it had like 8 different lines and all the power and whatever, and it was just like one big bulk add, and it was
Mm-hmm.
like, okay, like traces doing layout I'm sure is its own beast, but like that was like one big section all at once.
Mm-hmm.
Is that what you that would you're just saying you wouldn't really reference it until it's all in there?
So you can certainly do it that way. I guess you kind of learn to break it up in the way that you think will be most digestible to somebody or yourself looking back on it. So if there are ways to kind of compartmentalize changes and they're good kind of thresholds to break it up into, when you get into layout, you can kind of see, even from just a very broad high level, you can see the areas that are being changed. You're like, okay, this thing in the top right, that's my power supply. There's a whole bunch of green going on there. So a whole bunch of things
Hmm.
were added there. And you can kind of zoom in and do a deep dive. And then it's
Yeah.
very quick to be able to look at that commit message, which is the other piece of Git. Says like, hey, I laid out the 5-volt power regulator.
Yeah. Yeah.
You can look at that diff for the PCB and you can see, oh, there's this big green blob. I should go check that out if I want to go look at how that change was made.
Yeah. I mean, even though I usually disparage online layout tools, the one thing that
Mm,
is really cool about it is because you're tracking, like, all right, you're drawing a line from, point A to point B, and that's like a single change and they're tracking that change. You can literally go do a playback of an entire layout, which is like, that is super cool. It's probably,
yeah.
it's not as practical as what you're talking about, but being able to actually track those changes and say like, oh, here's where it went wrong. You can, like you skipped over a via here, or you deleted or whatever. And it's like, you can actually track that change by change. This is much more bulk added at once. And it's like, I wanted to connect microcontroller to logic level translator. Here's the difference between these two layouts. And it's just like a magic fast forward that goes between the two.
Hmm. Yeah, that's one of the interesting things. I've talked to some people about the difference between doing like discrete design changes, like how Git does, where you very deliberately say, I'm committing a new version versus real time design editing. Because there's some design tools that have really taken up this, like, oh, it should be real time on the
Hmm.
cloud enabled. And
Yeah, right. That's like a Fusion 360. You have like the history of each thing that happens, and then they even do
yeah,
the thing where you can go and like change a certain portion of it, and then it ripples through the design as well. And there's sometimes issues with that, but you can just go change that one dimension, and then it all ripples out, and it's like, that's pretty cool. But
mhm,
it's definitely a different way of. These are all like different design methodologies almost.
yeah, yeah. And, whereas Git would be that more like discretized way of like, yeah. So that's where we kind of
Right.
land is, that
Yeah.
seems to be at least what's been adopted most prominently in software, of course.
Well, I think the other problem with that is like the choice is you're using a third party program, right? You guys are a layer on top of an established program, or you go and build your own layout tool, which is like, well, we've seen that a couple times. That it's
Yeah,
really tough.
yeah,
It's a huge process, and then you have to like win over all these people, and it's just a mess. And it's like, and
yeah,
then you also have to convince them that this new way is the best way. It's like changing someone's religion. It's like, yeah, you better have a lot of dollars and a lot of patience to do that sort of thing.
yeah. Patience, especially. I mean, getting people to change, as you mentioned,
Yeah.
especially a company getting them to change to a new CAD tool is just it takes it. Everybody needs to change, and everybody needs to accept it all at the same
That's
time,
right.
which is
That's
just
right.
never
Exactly.
gonna
It's like, well, this might work if we burn down the old building and fire all the engineers.
happen.
When they rebuild, they might rebuild with a new tool. Who knows?
Yeah,
And
I think so. I remember iRobot right when I joined. They had just moved to Altium. They actually
mhm.
did that whole
Oh, they did it. Wow. Yeah.
transition. Yep, and I think it actually coincided with them moving to a new building. So
Do you know what the reason was why they switched over?
I don't recall. I don't know
Yeah.
what the real
I
reason
mean,
was.
sometimes it's just like a talent availability. Like it's like,
Mm,
hey, we can't find any engineers that do cadence or what. Obviously, that's not a good example, but Zook, we can't find any Zukin engineers. Like, there's
yeah,
still a program out there, but unless you're like making cameras in Japan, it's just
yeah,
like it is very targeted segments. And if you're in Boston and you're making robots, it's like you can't really find people. So where can we go and find the talent? It's like, yeah, we got to make this switch to Altium or whatever. And it's like,
right.
yeah, that would make sense. But then you think about all the legacy stuff you have to drag along too. It's
Hmm.
insane. So it's nice that you guys are making stuff on top of a popular tool, obviously, but then
Yeah,
it could be eventually decoupled from the tool. I think that's kind of the idea, right? It's that
that's totally the idea. Yeah,
yeah.
in especially we can take that input layer and start to create different not plugins might not be the right word, but basically different parsers for the different
Hmm.
design inputs. And then we can kind of, in the ideal case, create more of a unified, maybe intermediate file format.
Yeah.
I know we've talked a bit about that on the discussion boards over at Contextual Electronics, but
Hmm.
that would be
Yeah.
the ideal.
Yeah, and that would be nice. And that's actually how a lot of the footprint makers are doing it right now too. They have the interchange form. They have their own interchange format, and they say,
Mhm.
okay, well, pin one's always pin one, and it's power or whatever VCC, and then how does Altium want to see it? Okay, well, I'll put that pin one's output in this certain format. And how does Kaikai want to see it? Oh, it's output in this certain format. But then they store it that one way, and then they have ways to ingest and excrete footprints basically. And so it's like sounds like you kind of are looking to maybe do the same thing.
Huh, yeah, I actually didn't realize that with manufacturers exporting footprints. I have started looking at.
Well, not manufacturers. So this is more like a
Oh,
Snap EDA. I think some of the
got
manufacturers
it,
do it,
got
but
it.
like a SumAxis or a Snap EDA or Ultra Librarian, they all have their own internal format, but then they have exporters and importers. And
Mm-hmm.
right, so then when they store like an XML file that has, and I'm guessing here, I haven't seen any of this stuff, but just because the reason I really know this is, I think about this is because some of them, when you download it, you can either choose which program you download, and or one of them, I forget which one, it just sends you all of them. So it's like I want to download, a TPS 62821. That's a part I used on a recent board. So I want to download that footprint, and it sends you 16 different versions of that file in every, like for every popular CAD program. It's like, well, I guess yeah, that's one way to do it. It's like,
Wow.
but it's very unlikely that they have one person going to make that footprint for every single program. It's instead stored centrally and then generated as a way to
Mm-hmm.
export to all these formats.
Yeah, it's kind of like that compiled concept. Like
Yeah,
you have all of the information, then you're like compiling it and pushing it out.
exactly. Yeah.
I saw recently. I don't know if you've come across the JDEC 30. I think it's JDEC 30 format.
Okay. No, I've
I
never
think
seen it.
essentially it's
Yeah.
a format for component information, which is supposed to contain both the footprint, the symbol, and then also like some parametric like component information. So that's something we're looking at a lot too. That's for
Great.
at that component level.
Yeah, that'd be really great. I mean, problem with all that stuff is just that the data is just. I mean, there's hundreds of millions of parts out there, and most of them are really boring. And a resistor,
Yeah.
the 1.13K resistor is a completely different file and data entry than a 1.18K resistor, but you still got to have the different. You still got to generate each file, and it's like, oh, ugh,
Yeah.
yuck.
Or it's like a scanned PDF.
Oh, even worse. Even worse. Oh my god. Yeah.
Yeah. It's a challenge.
It's a crazy industry. Yeah. It's
Yeah.
everything's still PDFs. Okay, so someone's generating. Okay, so they make a small change. Let's go with your example. I like that. So they add an ESD set of diodes to a design. They go and commit that change. They say, hey, I added ESD diodes. It now is listed as D105 in the design. And then what happens?
Yeah. So then you basically commit and push, either in a series of steps, or you can commit and push that entire block change. And
That's block change, not blockchain, folks.
yeah, now enabled by blockchain technology. Yeah.
That's right. Right. It takes 45 minutes. 45 minutes and 6 gigawatts of energy to do it.
Yes. Yeah. But you generate a Bitcoin out.
That's right.
So we, you can push that change. You're using Allspice. We have essentially a version that can work as a hook to basically generate that diff to show you the differences, so you can actually see this visual representation of how the change was made. Then you can also actually create you can make a comment that says close out that issue that
Mm-hmm. Yep.
should have been opened. Any other documentation, so say there's like screenshots or documentation, you can actually upload it and attach it to that ticket. Some folks use Jira for this as well. I think
Oh,
some
cool.
teams.
Yep. Yep. And Jira is like a card-based tracking system, right?
Yeah, very similar to how those issues work. It's actually probably fairly similar, other than Atlassian, I think, makes Jira.
That's right.
Yeah.
Yeah, Jira's great. I mean, it's
Yeah.
a lot of people hate it, but I actually kind of like it. It's like Trello or anything else. Yeah, you can
Yeah.
basically, it's like sticky notes on a digital desktop.
Yeah. But you can close out that issue. And you can also create a design review or pull request around that.
Could you explain pull request? I think people probably will understand design review. What's a pull
Yeah.
request?
It's basically the Git equivalent of a design review. The idea here, at least in the Git landscape, is that you've created a branch. So like you've created a fork in your design with your design changes.
You're saying a lot of new words here.
It's if you picture a fork.
It's like a fork or a spoon, and then you knife it. And yeah, okay.
and then you create
Yeah.
your fork.
Yeah.
And it essentially should contain all of those, only those changes that you've made, and you submit a pull request, which is basically you can tag folks in your organization that maybe need to review it, and then once you make that change, it'll pull it into the main branch that you're using.
Mm-hmm. Yep.
And so that's where you can start to put a lot of you can start to have your dialogue around the changes that were made. You can actually, again, the idea is with Allspice, you can look at the diff. So we create that diff for you automatically, and you can actually comment on some of those things.
Yeah.
Again, we're looking at using GitHub and those hosting services for that.
This is kind of a non sequitur, but have you considered using Git for the PLM process? Because, or is anyone doing that you know of? Because what just popped up in my head was like, I was like, oh yeah, like a pull request is kind of like when you made a change in a PLM system. So the process that I was thinking about though is the signature process, right? So you go and make an engineering change request, and you have to like. I remember like printing when I was a co-op. I like print out paper, and then they would sit in someone's literal paper inbox because they didn't have the whole system in place. It would go sit in their paper inbox, and you'd have to get their physical signature. It was like 4 different people, and it would just be like on a Friday, the engineering admin would just be running around just begging them to read their change request so they could sign off on it and actually push stuff to production. It was like, but that's basically what a pull request is. It's basically sending around this thing, usually to fewer people, but you send it around and you basically get a sign off, and it's decoupled from paper or signatures or anything. And then basically it gets that change, then that small change gets pulled into the process. And then it's like, that is the new Bible, right? That is the new truth that everybody works off of. So
Yep.
has that happened at the PLM level?
I've never seen anyone doing that with Git now, but you're right. I mean, it is very analogous to like the ECO process. Differences being, hopefully, if it's so much easier to do, and you have all the information in one place, it's easier to do that review. And if you break it out into those little bite-sized changes, it's not a multi-hour or multi-day process to review a design. It's like minutes or maybe an hour to go through and say like, oh yes, he did that thing that he had intended, I'll give this my stamp of approval.
Yeah. So then maybe that ties into some of the other stuff that is happening or needs to happen, which is like, okay, so now going back to the ESD example, if you had a test that was like, oh no, these lines need to have low leakage, and then you put a bunch of ESD diodes on them and they start leaking, how do you decouple? Like, so like it's a small change, it looks fine, it's good. The part, you send it off to these different people within your organization. You send it to the part engineer, he's like, yeah, it's sourceable. You send it off to the buyer, he's like, yeah, I can buy it. You send it off to the manufacturing person, they're like, yeah, we can put this on a board. But like they all sign off on it, but like who's looking at it to make sure, to double check that it's actually supposed to be there? Is that something that you're also planning to get into?
So you said that what's supposed to be there, like you have the appropriate like leakage.
Yeah, that it's like not a dumb change, I guess. That it's not like you put in this ESD diode to solve a problem, but maybe it's going to cause 3 other problems, and that would be something that at a design review, someone looking at it might be like, well, did you think about this X, Y, and Z, right? But it's not necessarily a functional change of like, can this be done? But it's more of a, should this be done? Is there any kind of check in there like that? I guess it would be more like simulation and things.
Yeah, I mean, this is going to evolve over time. The first step is just provide that same level, at least show you how the design is changing so that you can have people do that manual process that they're in some ways doing now. And then once we build up more robust database of component information, we can check that you have the appropriate leakage for or like hold off resistance or whatever it might be.
Right. Yeah, like critical element for that specific part of your design.
Right. And the idea here is that, just like you said, you can build that test as you're creating the pull request. So it's like, I made this fix, it fixes the thing. Here, look, in that, whatever information we need to add during that test is added. And you can see, so you not only add it during that test, but then it will be tested at each future version to make sure that it doesn't fail those conditions.
Ah, interesting. Okay. Yeah, is that how it works in this? I actually never really understood that part. Like I've heard about unit testing and I've heard people talk about it in integration, continuous integration, but I actually don't know, like, is there a review process for when a new test gets put in, or is it just like, no, it's always got to be checked now?
Yeah, it depends how diligent the process is and the reviewers are, but that is in principle the concept of unit testing, which is, if I'm going to add a new function to my software, I'm also going to include the appropriate test that ensures that whenever this function is used in the future, that it's or changed in the future, that it's still outputting the correct pieces.
Hmm. Yeah.
Yeah.
Yeah, and it does. I mean, this whole thing. I mean, people listening, they're probably like, "Oh my god, my job just got so much harder." But it does seem like we're talking about like the beginning of the process, and
Yeah.
it does seem like it builds up over time. So
Exactly.
it would get easier especially if you're moving to manufacturing, it would get easier.
Yeah, and the same thing exists in software too. It is daunting. You're like, oh, I should be, same with documentation. Like, oh, I should be good and create my documentation, but I could just push it out and like
That's
go
right.
to the beach.
Right, right. My boss will yell at me at some point. I'll do it when they yell at me.
Yeah, exactly. And it's always a balance with all of these things. But the idea is, like you said, you can build it in bite-sized chunks that it is ultimately going to save you time, as you're not calling your manufacturer to figure out why something was built in a certain way at you know
Mm.
the midnight hours.
Yeah, right. Well, and so then that is where kind of the buck stops. It's like, okay, I make this change, but at a certain point, it's going to change PCB manufacturing, then it's going to change assembly as well, and that might have to go through a product lifecycle maintenance tool like PLM. It might have to go through that at some point, but I can imagine that this change literally, if everything was tooled up properly, I could add an ESD diode to a design, and then maybe it gets bundled with other changes. But at some point, it ripples all the way through to a board that's being manufactured differently than it used to be manufactured. So how does that stuff get? When does that keep going through the process?
That's kind of like the continuous release side of the or continuous deploy side of this
does
process.
does that actually happen? I mean, like I just imagine like Rev 478 of my PCB, and it's just like, and then like like that would just be madness, wouldn't it?
Yeah, I mean, that's yeah. So who knows where things will go with turn times for manufacturers getting lower if the time it takes to actually like release and like send your information over to manufacturer is is lower. I mean, you could have a lot more rapid design changes, but right now we are focused on the data side of things,
Okay.
not on the release side.
Yeah.
But the same analogy, I think, still applies to the software space. Some people might push back on this, but it really is like there's this difference between continuous integration and test, which is what we talked about, and then continuous deployment, and those are
Hmm.
two different steps. Where the second one
Yeah.
says, "Okay, no, now we're ready to push this thing out the door." In software, that may be like we're going to go put this in front of people, and in hardware, it's we're going to go put this in front of the contract manufacturers.
Yeah. It's almost like when if you harken back to like actually making CDs, it's like at some point you have to like cut off what's going to get included there, and
Yeah,
it's like you
yeah.
have to hit the button to go print another 100,000 CDs to send out with your software, and like that's a big deal. Versus
Mhm.
now, it's like, oh, I'm just going to upload, you know, version 4.17.2, and revving from .1 to .2 is not that big a deal because it just updates overnight on someone's phone. Not that that's not a big deal. That could break a lot of things, of course, but the physical atoms element of it, bits versus atoms, like it, there is like a bigger cost to revving at that point, just like there would have
Mhm.
been with printing new CDs.
Yeah, totally.
Well, it's an interesting. I'm trying to remember too. Kyle, we've done a lot of shows here, and I've forgotten more than I've remembered. I remember someone, it may not have been on the show either, but I remember someone talking about like we had a design a week going out, and like basically it was on the text to be able to like go and look up. Basically they'd have so many revs going that they'd have like, you know, a design goes out to get, PCB manufactured and assembled and whatever. And even if you're going through a quick turn process, it's going to take, 3 or 4 days. And so I'm making a change on Monday. The board's coming back on Thursday. I find a change on Tuesday. The board's coming back on Friday. You know what I mean? Like, and it's just like, it's like this ripple effect.
So are they leapfrogging? Are they actually able to get, the
I
boards
think,
spun up
I
and
think they were
tested?
leapfrogging, but
Yeah, I'd
but they
imagine.
it was moving so fast that they had to push these changes. And I just imagine like needing to have that information travel with that actual board coming back. Like a technician opens the box on Thursday, and it's a completely different set of, maybe not completely different, but it is a different schematic or layout than it is on the box that it's opened on Friday. And so,
Mm.
like, how would someone go and review that using the Allspice tool?
Yeah, I mean, make sure that like the physical board lines up with the with the
Yeah.
digital version that I'm looking at on the computer. Yeah, actually, it is it is interesting because we are working so much on the design side of it. I don't know. I might have to actually have a follow up conversation with you about that, because
Okay.
that's there could be, maybe it's maybe it is having your uh could be the release code, the release version
Yeah.
in Git, because you can do this concept called tagging. You can
That's
tag a
right. Yeah.
release,
Yep.
and those can be with like your custom release tags. So version, depending on whatever company you have, but like v0.1, or if you're using letter codes. And there's certainly ability for us to like put in hooks to essentially update, in big block letters, what the version is
Yeah.
on the
Right.
PCB when it's done with that pull request. So when the pull request is approved, you bump that revision, and then that's what goes on your PCB. So
Yeah.
maybe that's a piece of it.
Yeah. I used to put commit numbers on my PCBs. Like, I thought
Oh,
that was like
interesting.
very clever. But the stupid thing about that is that I would be like, all right, the commit number is like a hash basically, and it's like usually it's
Yeah.
shortened down to like 6 or 8 characters. I forget what it is, 6, I
Yeah.
think. And so I'd like be like, all right, this is commit 9A2 FF1 or something like that, and I'd be like, okay, I'm gonna go put that on my board. And then I'd go and like save it and be like, oh, I should commit this. And I'm like, oh, it's a new commit now, because I'd like go and put it on the
Yeah.
board. And so later when I learned about tagging, I was like, okay, this is the real way. This is the
Yeah.
real way it's supposed to happen. So yeah, that's interesting.
That is funny. Yeah, I'm not sure if there's a way to do that. Like have the
Have it like
commit.
fast forward to be like, what will my commit number be?
Yeah.
Yeah,
Yeah,
that's
don't do that.
not easy. Yeah. Cool. Well, how can people find out more about this and get started if they're interested?
Yeah, so you can go to our website, allspice.io, or feel free to send me an email at kyle@allspice.io. Again, the diff tool there for Altium is free to download and free to use, and will continue to be. We're also looking for other folks that are interested in the analytics and the CI component of what you and I talked about a little bit.
Mm-hmm. Okay, great. I should probably mention too. So, is there a Spice component to this yet, or is that kind of in the works?
That's in the works.
Okay, cool. So that's down the line. Yeah. So Spice at the top, we mentioned Spice. It's like, oh yeah, there's Spice coming. And then the final, most important question: when's it gonna happen, Kyle? Come on.
When's
When?
the spice gonna happen?
Nope, not that.
Oh, we're talking about the wedding.
No, Kyle.
No.
The KiCad. When's KiCad gonna happen?
Oh, when's KiCad gonna happen? No, we don't have a set date for that. But I mean, there's so much good information there. I will say, if any of the listeners are passionate about this piece of things,
Mm-hmm.
there's certainly the ability to bump that up.
Maybe we can get a sign up form. Maybe like do you have like a blog post? Like, do you have any kind of survey information?
I thought you were gonna say like a petition.
A petition was kind of what I was thinking of,
Yeah.
like we want the tools, we want them now.
Yeah, we've been talking about that, my co-founder and I, and so we can have that by
Okay. All right.
by
All right.
Monday.
So we're still going to be waiting.
Have
That's
the
okay.
numbers.
There's enough Altium users on here that I'm sure that they're going to be fine.
Yeah.
But yeah. All right.
Sweet. It'll happen.
Okay. Well, we'll wait for all the good, the other spicy things that are happening anyways. So
Yeah.
does Altium have Spice included or no?
Altium does have a simulator included
It does.
in
Okay.
it. The ability to link together models it's been tough, but I know they're
Yeah. And you'd want to have the actual like information embedded with, you drop in an op amp. You don't want to go and like look for the Spice model for that op amp. You want to just be there. So like that also means that you need part information and all the models. And yeah, it's that same exploding amount of data that happens with millions of parts out there. Cool. Well, Kyle, thanks so much for joining us here. And this is exciting new methodology. Hopefully people fall in love with the Git methodology like I have. I think it's been really good for my designs, and I will save it. It's saved my bacon a couple times.
Yeah. Good. Glad to hear it.
All right. We'll talk to you soon.
Thanks for having me.